All right, so this last chapter that we have before final exams also involves trig. So we did a lot of trig in the last chapter with unit circle and so on. So we're going to use that knowledge to help us graph sine and cosine on the x and y axis. So it's going to be a little bit strange at first, okay? I put a little unit circle on there, and I have a little corresponding graph grid for you guys. So basically, if I'm changing, you can call this t or theta. It's basically your angle, right? It doesn't matter. So you can have t or theta. But as our angle changes from 0 to pi over 2, along the unit circle, we would go from here to here, right, from an angle of 0 to pi over 2. And we want to think about what's happening to our sine value. So sine on the unit circle is going to be the y value of the unit circle. So as I go from an angle of 0 to pi over 2, how is that affecting my curve? It's going from what to y values? 0 to 1, exactly. All right, so if I have the corresponding graph and I'm graphing from 0 to pi over 2, I'm going from 0 up to a height of 1. Okay, and it's going to kind of look like a circle. Look like that, okay? All right, but if I go from pi over 2 to pi, my sine value goes from a height of 1 to a height of 0. So from pi over 2 to pi, I'm going from the height of 1 back down to 0. Okay. Okay. And then from pi to 3 pi over 2, what do my y values go from? Thank you. Yeah, they go from 0 to negative 1. So I'm going to go from here down to negative 1. And then the last thing is from 3 pi over 2 to 2 pi. That would be from here to here. So what do my y values go from? Negative 1 back to 0, exactly. So it's like that. So if you put all of these together, it makes one big sine curve. Okay, so here's what it's going to look like. I'll graph it on the original. So I'm going to have pi, 3 pi over 2, and 2 pi. And we're going to go from 0 to 1, and then we're going to go from 1 to 0, then 0 to negative 1, and then negative 1 to 0. So it's going to look like that portion of the curve. Does that make sense? So it says, no, the same curve will be repeated for different values of t, or theta. Okay, so as we go around the unit circle, remember, every rotation of 2 pi gave me the same y values, right? So it says, what are two values of t, or theta, that give an output of 1 on the graph? So if we think about it, on our unit circle, we had 1 at pi over 2, but then we also had it at 5 pi over 2, 9 pi over 2, and so on. So it actually has to repeat. So this curve, not only do I sketch the 0 to 2 pi, but I can go even further than that. So putting it all together, oh, it says sine of t minus 2 pi equals sine of t. In other words, the period is 2 pi. So everything repeats after 2 pi. So here's what our rough sketch of the sine curve looks like. Oh, that was not straight off. I'll try better. Now I just went the other way. Oh, well. So what I typically do when I'm graphing sine is I kind of do like the end is 2 pi, and half of that I put as pi, and then I do my little tick marks in between at pi over 2 and 3 pi over 2. And then I try to do kind of the same distance here for negative 2 pi, negative pi, and my two little tick marks. So negative pi over 2 and negative 3 pi over 2. Okay, do you guys all have those in? I'm speedy. Emily, did you get the note? Yeah. Sorry, I know I talk fast. You guys say that on my evaluations every year. You talk really fast. All right, so I have 1 and I have negative 1. You really can't win on evaluations, though, because some people say, she goes so fast, I can't keep up. And then some people are like, this class is so boring. I know all of this. It goes too slow. It doesn't matter.
That's negative 3.
Negative 3 pi over 2. All right, so here we go. So sine starts at 0, 0. That's what we determined on the last one, right? The sine of 0, a theta of 0, was 0. Okay? So we're starting here at the kind of like the origin, right? And we're going up to a height of 1. And then we go down to a height of 0. right? Sine of pi was 0. And then we go down here, and then we go back up. Makes a little wave function. And then it goes on forever, so we'll do a little arrow.
That's cosine.
This is the sine function, yes. But it also goes backwards. Like if I had gone backwards on my unit circle, right, at negative pi over 2 gave me a -1 for my sine. And then negative pi gave me 0. So a lot of times I'll just kind of sketch in the original points. And then that helps me kind of draw the curve. So if I sketch in a few points, does that make sense? So this is the curve y equals sine of x, if we call this the x-axis and the y-axis like usual. Okay, does that make sense? Okay, this whole graph is one of a certain family. It's called sinusoidal graphs. You like that word? Say that 10 times fast.
Sinusoidal.
It's a sinusoidal graph. Okay, but sinusoidal graphs aren't just sine. They could be cosine as well. So sine and cosine are going to be in this family together. They're going to look the same. They're all going to be like these little wave functions. And they're very useful in real life. What travels in waves? Sound, yeah, sound, which is light too. I don't know, I should know that. All right. Yeah. All right, here we go. Sound waves. All right, so how about cosine? So the same process can be done for cosine as well. Now, obviously, I'm not going to do this every single time. Guys, I'm not going to do this every single time I want to draw sine or cosine, right? I'm not going to go through like the unit circle and think of every single thing. So if I have 0 to pi over 2, 0 to pi over 2, if I think about the cosine values, cosine is the x-value in our unit circle, it goes from 1 to 0. So we're going to start at 1, and we're going to go down to 0 now. So it's a little bit different than sine. Yeah, I heard Alex say, didn't we just do this? All right, then pi over 2 to pi goes from 0 to -1. So from pi over 2 to pi, we're starting out at 0, and now we're going to a height of -1. And then pi to 3 pi over 2, its x value in the unit circle goes from -1 to 0. And then 3 pi over 2 to 2 pi goes from 0 to 1. So that's how each piece is graphed. Okay, so it says like sine, the period of cosine is also 2 pi. So, you know, cosine of pi over 2 is the same as cosine of 5 pi over 2, and so on. So that means as t goes from 2 pi to 4 pi, it just repeats exactly that same curve. Okay, so let's go ahead and draw in cosine then. So if I have cosine, so we started out the way that I just did the last one. I usually do 2 pi, and I do half to put pi. And I do pi over 2 and 3 pi over 2. There's my little tick marks in the middle. And then do the negatives as well. So -2 pi, -5, -3 pi over 2, -pi over 2. All right. So cosine, it starts at a height of 1, right? If you think on your unit circle about cosine at 0, cosine is 1. So that's why cosine starts at 1. So now we're starting up here at the top of our curve. Cosine of pi over 2 was 0. Cosine of pi was -1. I mean, it's basically every single location you're going back, and you kind of curve it around. So it's not like straight lines, it's curvy. Does that make sense? It makes like a U shape. So if you just do from 0 to pi over 2, it looks like that. Emerson, James? So we come back down. And then back up. Okay, so it's still making that kind of sinusoidal graph, like a wave graph. Okay, and it continues on forever. Okay, so the thing that kills me about a lot of pre-calc books, I really haven't found one that I'm like totally happy with, because most of them don't teach it using a unit circle. And you know, I'm a big unit circle fan, so I teach it using a unit circle, which I think you guys have it down now. You kind of like the unit circle. Here's what other books do, and this is why I teach you the unit circle first, because I find it to be very confusing. So it says state all values of x for which sine of x is equal to -1. So a lot of them relate it to the sine curve instead of the circle, okay? And we know how to solve this. We know how to say sine of x equals -1, so maybe we'll use the unit circle to do this first. We know that sine is equal to -1 where? Not pi. 3 pi over 2. But where else? So as I rotate around, adding 2 pi, 7 pi over 2, adding 2 pi again, 11 pi over 2, and so on. I'm adding 4 pi over 2 each time. So the way that I would write this answer, I actually do 3 pi over 2, but I want to say every single rotation of 2 pi is included as well. So we write it very fancy in pre-calc. We do this, 3 pi over 2 plus 2 pi k, where k is an integer. Okay, you won't have to write out where k is an integer every time. I get it, k is an integer. But this is what we're looking for, 3 pi over 2 plus 2 pi k. Some books will do 2 pi n. All right, so that's the way I would do it. I would just kind of quickly do a little unit circle. I'd think, okay, it's 3 pi over 2, that's the first one, and then I'm going to keep adding intervals of 2 pi. Okay, so what does the 2 pi k mean? So k means I can plug in any integer. Well, what if I plug in 1? Yeah, I have 3 pi over 2 plus 1 of the 2 pi's, right? So that would be at the 5 pi over 2. Not 5 pi over 2, 7 pi over 2, sorry. What if I had -1? Then I have 3 pi over 2 plus a -2 pi. Right? That would be a -pi over 2. Does that make sense? So every rotation around is included. All right, so here's what other textbooks do. They don't use the unit circle. Instead, they use the sine curve, which means every single time they solve these problems, you have to draw out the sine curve.
Sine curve.
There should be. No, you will need to know how to draw. And then they say, when is sine equal to -1? It's here and here. It's any place. Oh, that's a terrible straight line. It's not quite straight, is it? Any place where you're crossing the line y equals -1. Okay, if you get the same answers, you can see that it's at 3 pi over 2. That's the first one. And then you can see that it's every 2 pi after that, right? But it's just a little bit harder to think of, especially on the next one. Yeah. It is negatives as well. Yeah, this will continue going this way, and so it will cross there as well. Yeah. Okay. So that's why you have plus 2 pi k where k is an integer with an infinite number of answers. Sarah. So it says state all values for x for which cosine of x is -1/2. So let's do it our way, and then we'll talk about the other way. Okay, so cosine of x equals -1/2. Well, we quickly drew a little unit circle, and we said, okay, cosine is -1/2 in 2 locations. Did you forget already? It's been like 2 days since our test. All right, x is what? 2 pi over 3 and 4 pi over 3, right? But those aren't the only values. I didn't say just on the interval 0 to 2 pi. I said state all values, right? We want to find every single value. Okay, so this is where we add our 2 pi k. Okay, but we actually have to add it to both of them, because I can't just say 2 pi over 3 plus 2 pi k, because then I miss. You guys see, I would miss, like it would go around, and I'd hit that one again. Around, I'd hit that one again. But I'd be missing those 4 pi over 3 ones. Did you get it? So your answer for this would be x equals 2 pi over 3 plus 2 pi k, and 4 pi over 3 plus 2 pi k. And it would be both of those. Okay. So what happens if you have a graph? Well, we have the cosine graph up above, and we're saying when is cosine equal to -1/2? So if I drew this in, you don't have to draw this in, just kind of pay attention. It'd be like right here. This value right here is our 2 pi over 3, and this value right here is our 4 pi over 3. But like, how do you know that? Like, how do you know that that's what that is, right? Isn't it a lot harder using the curve? I think it's harder using the curve. I like the little circle. like remembering where everything single thing is. But looking at that, you know, what if you draw it kind of wrong and it doesn't look right? So that's why I don't like how some books use the curve instead. And a lot of times they'll let you use a calculator. You'll graph both things, right? All right, so on the interval negative pi to pi, state all values for x for which sine of x is equal to negative root 3 over 2. So we did this in the last chapter too. So basically we drew our little unit circle. And we said when is sine equal to negative root 3 over 2? And we said it was in 2 locations. So it was at x equals 2 pi over 3. No, what am I talking about? 4 pi over 3. And 5 pi over 3. But the thing that's wrong with this is on 0 to 2 pi. Okay, it's not on the interval that I want it to be. Right, I want it to be negative pi to pi. So I have to adjust it. So that's when, do you guys remember, we just went ahead and wrote 4 pi over 3 and 5 pi over 3, and then I told you, oh, well, let's just subtract 2 pi. Let's find the coterminal angle. So if I subtract 2 pi, what I'm doing is 4 pi over 3 minus 6 pi over 3. I get common denominators. So I get negative 2 pi over 3. And then the other one is 5 pi over 3 minus 6 pi over 3. So it's negative pi over 3. Now, do I need to do the pi k thing? Why is this one different? Right, it tells you this like fixed interval, right? This interval does not have an infinite number of solutions on it. Right, it's just a little tiny interval. So those are the only ones that are on that interval. You could also think of it as a negative, like negative pi over 3 means going back 6 degrees, negative 2 pi over 3 means going over here. Like, you could do it that way too. You could just think in reverse, how much am I going in reverse? But if you guys like subtracting 2 pi, that's fine. All right, then we also did some things like this at the end of the last chapter. We're getting to new stuff, I promise, but quick review of the last stuff. So it says find the decimal approximations for the solutions to sine of x equals 0.3. This is not a unit circle value. So when that happens, we can still think of it on the circle. So we're saying when is our sine or the height equal to 0.3? So the height would be 0.3 somewhere, I don't know, like around here somewhere. But it's in 2 locations, definitely. On 0 to 2 pi. But there's going to be an infinite number of solutions for this. Okay, so what I want to do is I want to solve for x by doing inverse sine. But I know my calculator only gives me one answer. Radians. Almost always radians. All right, so I get x equals 0.305. Okay, so what a radian measure is it is the distance, like the arc length from here to here. Okay? So if I want the arc length from here to there, right, how do I do that?
You add
2 pi or what? Pi, exactly. So my other one is going to be x equals pi minus 0.305. 2.837. So I get 2 values, but are those the only 2?
No, there's
No. So this is where you do your plus 2 pi k, plus 2 pi k. So those are all of the answers, an infinite number of solutions. If you want to write where k is an integer, you can. Or you can even write where k is an element of z. Do you guys remember doing that? Not for 2. Fancy. You do that as well. If you just leave it off, I'm cool with it. But if you like someday take AP Calc or something and you need an infinite number of solutions, like write where k is an integer. Like just don't leave that off. It is kind of important. But for me, it's fine. All right, so what are the ranges of f of x equals sine of x and g of x equals cosine of x? So what are the ranges means when I graph sine, how high does it go and how low does it go? Right, it goes from -1 to 1. Is that the same for cosine?
Yeah.
Yeah, it just goes in another way, right? It's 1 to -1. So yeah, they're both -1 to 1. Okay, so now the most important part of this section, your fave, transformations.
Oh, no.
So I'm so pumped. All right, I have totally trained you because you're so lucky that you had me for Algebra 2 and Pre-Calc. Man. Yeah. I'm sure you guys are like, yay. AP Calc 2, I'm sure. All right, so transformations, I've really drilled this into you. Remember we did the math aerobics in Algebra 2? You guys know your transformations. So number 1, easy. I think every single person in here could tell me what this does. Okay, so this is like our parent function. Our parent was y equals x squared, so it's a parabola. On the inside, I have x minus 5. What does the minus 5 tell me to do? Exactly, go right 5. What does the 1/2 out front tell me to do? No, vertical compression. What's the flip? A negative, right? So we have a vertical compression by 1/2. So it's just going to kind of squish your parabola down. And then what's the plus 4? Up 4, exactly. Transformations that you had in Algebra 2 are exactly what transformations in Pre-Calc are. Yes?
Is a vertical compression by 1/2 and a vertical stretch by 2 the same?
No.
Or a horizontal stretch by 2?
They're similar, except the numbers are different depending on what you're, like if it's x cubed or, so like if I had like 1/2 x cubed, that's really the same as 1/8 x cubed. So like that would be a vertical compression by, or vertical stretch by 2. But it's actually hang on, dang it. Now I'm really confusing myself. This is going to be a horizontal stretch by 2, but it's a vertical compression by 1/8. Does that make sense? So the numbers are different. All right, so next one. This is what we learned, especially this year we talked about this. Okay, this is the stuff that you still have trouble with. So number 2. Do you guys remember when there's 2 things in the middle?
Oh, yeah, that becomes a...
So there's 2 horizontal transformations. So that's like a red flag. We see that and we're like, man, we have got to do something about this. So what we do,
That's a black flag.
I know, it's actually red on my screen. You guys don't see red with my projector. What we actually do is we pull out a 2.
Yeah, we can see the blue though.
I know. You can see blue and you can see green, but they're not like the same shades as my computer. All right. All right, so anyway, so I pull out a 2 from both of those, right? Do you guys see? So it becomes 2 times x plus 2. And I still have a minus 1 on the end. And I continue to simplify. Oh, sorry. I was already moving ahead.
I got that.
I heard Julia first. All right, so I have that.
Everybody got a point.
No.
No.
All right, so I have negative 1/4. And I square both this 2 and the x plus 2. So when I square the 2, I get a 4. And then I have x plus 2 as being squared. Does that make sense? So that 1/4 times 4, I can now multiply those. 1/4 times 4 is 1, but I still have a negative. So I have negative 1 times x plus 2 squared minus 1. So I just rewrite it. So when I see this, my parent function is still y equals x squared. I move to the left 2. I have a reflection over the x-axis. And I move down 1. Do you guys remember all those transformations? Okay. But we first had to rewrite it. And the same thing will be true with sine and cosine, except we're not going to do the simplifying step. We're just going to kind of leave it like that. Okay, so that will make more sense when you see these. Okay, so it says the same transformations can change sinusoidal functions as well. So if you see f of x equals a times sine of bx plus c plus d, you see that we have 2 horizontal transformations. So we first have to rewrite. So we rewrite it as f of x equals a times sine of b, and then in parentheses we say x plus c over b plus d. Do you see what I did there? Do you see when you multiply b in, you get the same thing that we just had? I just divided each one by b. So when we go through these different things, the a out front is a vertical stretch. So what that does to your sine curve, instead of going from 0 to 1, you know, if a had been 2 out front, it's going to make it go from 0 to 2. and 0 to -2 down, okay? So it's going to stretch it out. So we're going to have an amplitude, which is a vertical stretch of A. A horizontal stretch, or maybe it's a compression, but it has to do with this number right here. So it's going to be the reciprocal, 1 over B. It's going to move to the right, it's really to the left, C over B, but we'll say to the right, negative C over B, and a vertical shift of D. It's going to go up D. Okay, so don't panic. You don't have to memorize all that. All you have to do is think about our transformations. So this will be very easy. All right, so when I got my new computer mid-year, for some reason, all of my pi's and thetas in this entire notes went away. So all of them became these little rectangles. So that, I tried to catch them, but this should be a pi. So it should be pi over 2 there. I know, it was very annoying. All right, so list the transformations needed to change the graph of f of x equals cosine of x into the graph of h of x equals 2 times cosine of x minus pi over 2. So just think about our transformations. That's all we're doing. If I have something in parentheses with x, and it says x minus pi over 2, what direction am I moving?
Left.
No.
Right.
I just said you guys were experts on this. You guys are going, "I'm wrong now? Man, right pi over 2. All right, what about the 2 out front? Okay, so here we go. You ready to graph this? I'll do it in a couple steps for you guys. All right. A lot of times I'll just draw cosine first, because that's my parent, right? The parent is cosine of x. Can you guys draw your little first units? So we do 2 pi, have it, pi, put little half marks in between those, pi over 2 and 3 pi over 2. And cosine starts at 1 and it goes down to -1. So if I was drawing cosine in, I'll draw it in black. It's basically going to hit each of those important points. Like it's going to go down to 0 at pi over 2, -1 for pi, 0 for 3 pi over 2, and then back up to 1 for 2 pi. Basically, it has to repeat every 2 pi.
That's the parent.
That's the parent function. That's cosine of x. That's a good one. All right, so the first thing we're going to do is we're going to go right pi over 2. Okay, every point is going to shift right pi over 2. So like these points that are on the axes, we're going to go to the right by pi over 2. So everything's shifting over. What's this one here? Okay, so it's going to go down, back up, back up. So I'm going to kind of label, and I'm going to call that the blue box there. And then our last step is to do a vertical stretch by 2. So all that's going to do is all of our y values are going to be multiplied by 2. So where I had a height of 1 before, I'm going to go to a height of 2. Okay, so I'm going to go ahead and draw up to 2 and down to -2. So I still have these same points, but now I'm starting at a height of 2. 0 is still the same. I go down to -2 though. 0 is the same, 2. And then it's still kind of that same shape, just exaggerated. Okay, that's our new function. So that's h of x. So if you wanted to continue it on, no big deal. You could easily do that, right? You can kind of follow the pattern and continue it on. Does that make sense? Would you be able to do that on your own for your homework? One step at a time. All right, so here we go. So it says, roughly sketch a graph of g of x equals -1/2 sine of x minus 1 on the interval -2 to 2 pi to 2 pi. Okay, so let's start out with a parent. So our parent function is y equals sine of x. What transformations am I going to do? What's the 1/2 do?
Oh, no.
Vertical compression by 1/2. What we call that is the amplitude. So our amplitude now becomes 1/2. It's like the distance from the equilibrium line. You go up 1/2, down 1/2 off that line.
Like over.
Yep, reflection over the x-axis. And then last step, down 1, exactly. So let's do our 2 pi, pi, tick marks in between.
This drawing just,
You don't like drawing these?
I'm already taking art class.
See why I'm an art and math major now. So drawing and math. All right, can we at least do the vertical compression by 1/2 without drawing the parent function? Can we handle that? Yeah, it's basically instead of going up to 1, you're going up to a height of 1/2 and negative 1/2. So we can do that one. So we'll make the first one. We'll draw that one in black. So it's sine, so it still starts at 0, and we go up to 1/2, down to 0, down to negative 1/2, up to 1, or up to 0. And we follow that in the opposite direction as well. Okay, so we have that. You guys pros with this? Got it down? All right, now we do the reflection over the x-axis. It does, it flips it. So everything that was at 0 is still the same, actually. But if I was at a height of 1/2, I'm now going to be negative 1/2. If I was at negative 1/2, I'm now at 1/2. So the maxes and mins actually change positions. So drawing in the points sometimes helps as you're drawing your curve. Looks like DNA, kind of. It does. All right, and then the last step is down 1. So I just take everything and all the y values get shifted down 1. So instead of being at negative 1/2, I'm actually going to be at negative 3/2. Okay, so like the lowest points are way down there at negative 3/2. And then the ones that were along the x-axis, where are they going to be now? Negative 1, right? You're shifting them down 1. So if you want to draw, sometimes I draw like the little equilibrium line, that helps. And then the ones that were at, let's see, 1/2, they're going to be at, if I subtract 1, at negative 1/2, right? There's a lot. One thing at a time. Okay, let me think. Here, here, here. All right, so we have this. Okay, so that's our final function. So that's g of x. So you can very lightly on your homework draw the first ones and then, you know, use a bolder line for the last one, or you can use colored pencils. I always like when you guys use colored pencils because you turn in your homework and it looks beautiful. It's so pretty. All right. So number 3, so decide how y equals 1/4 of sine of 3x is then transformed from y equals sine of x graph both below. Okay, a little bit weird. So what do we think? So what's the 1/4 do?
What does that make like
Vertical what?
vertical compression?
Mm-hmm.
Like,
Okay, so what's our trig word? It starts with an A.
associate.
Amplitude is not associative. That takes me way back.
Yeah.
Chapter 1, algebra 2. Amplitude.
I feel like I'm old.
All right, what about the 3x? Okay, that's n with the x. It's a horizontal what? Compression by 1/3. We're thirding the period. So normally sine starts at 0 and it completes its full cycle once it gets to 2 pi, right? Where's this one going to end? If I compress it by 1/3. I heard someone say 2 pi over what?
2 pi over 3.
2 pi over 3. Right, so you take that, you take your 2 pi and you divide by whatever number was there. So that was our b, we call it. All right, so basically when I'm drawing this sketch, you can make it pretty easy. This is why I don't give you, like, I'm tempted to give you guys graph paper for sine and cosine, but it almost makes it harder when I do. All you have to do is just know how to, like, make your axes, so it's nice. So usually we go to 2 pi. What am I going to go to now? 2 pi over 3. Can you do half of that? Half of 2 pi over 3 is pi over 3, right? 2 pi over 6 or pi over 3. I don't really care about the other ones. Just do little tick marks there. But if you can at least get those two, we're good. And then the height, instead of going to 1, we're going to 1/4 and down to negative 1/4. But otherwise, it looks exactly the same as sine. So it starts at 0, and I use those tick marks to help me. So I'm going to go up, down, down, up. There we go. Done. So that's one full cycle of something that looks like sine. It's just the period is only 2 pi over 3, and the amplitude is 1/4. That's all you have to do on your homework. Okay? All right, so it says the period of a sinusoidal function is how long it takes for the graph to return to its starting position, completing one full cycle. The amplitude is the distance, is half the distance between the maximum and minimum. Okay, I never refer to it as that though, because this is like the max and this is the min. I always talk about its distance from the equilibrium line. That's your amplitude. So in both directions. So in other words, it's how much you move off of that equilibrium line. So number 4, find the period and the amplitude, sketch a rough graph. All right, so what do we think the amplitude is? That's always the easy one. Yeah, it's 4. What do we think the period is? It was normally 2 pi, but we had a horizontal compression by 1/2. So instead of having 2 pi, we divide it by 2, and we get pi. Right? If I divide my normal period by 2, I'm down to pi. Okay? Because of that 2x.
Okay.
Yep. So the formula is really, the period is always equal to 2 pi divided by b. So whatever that b value was. But I like to think of it as the transformation. So you don't have to keep all those formulas in your head. You don't have to think about like c over d and what am I doing, or c over b or whatever it is. I just like to think of the transformations. It makes it so much easier. All right, so the period is pi. So always do that point first. Whatever your period is, do that first. And then do half of it, which we can write, pi over 2. And then you can do the little tick marks for the other ones. And it goes up to a height of 4 this time. So sine starts at 0, 0. It goes up. It comes down. It goes down. It goes up. Okay, if you did make it all the way to 2 pi, so some people like to do that, basically it's going to complete 2 full cycles within that original period, within the 2 pi. Does that make sense? Because we had 2 pi, or we had a horizontal compression by 1/2. So normally if we had a period of 2 pi, now we're fitting 2 things in there because we're swishing it in like an accordion. Okay, so it would go up, down, and then back up. Okay, so we have 2 full periods there. Do you guys see the 2 periods? Okay. All right. So next up. So now we have a cosine graph. It's a little bit weird. Amplitude, that's the easy one. 1/2. Period is normally 2 pi. What do we do here? We have a pi in this one. We divide by pi over 3, yeah. So it becomes 2 pi times 3 over pi. And the pi's actually go completely away. I never liked these when I was in school. I was like, how can you have a period of 6? I don't get it. All right, basically it means that 6 units, right? That's when you're completing that one full cycle. Okay? And we're going up to a height of 1/2 and down to negative 1/2. But now my parent function is not sine, be careful, cosine. So where does cosine always start? It started at 1, right? So with this one, I'm going to start at the highest point, at 1/2. And I'm going to go down and then back up and make that U shape. So at the end of the period, I'm going to be back up here. Okay? So every single tick mark that you've drawn gets hit. It looks like that. Does that make sense? And you can always plug in points too if you get stuck. I mean, you could plug in 3, and then you'd have 1/2 of cosine of 3 pi over 3, which is cosine of pi. Right, cosine of pi is -1, so 1/2 times -1 is -1/2. I mean, you can do that. It just takes a long time. Right? You could do like a little table of values. All right, sketch the graph of the function, include 2 full periods. All right, so I have cosine of 2 pi x. It's another one that has pi in it. So the period is just going to be something without pi. It's going to be a number. So the amplitude for this one is easy. It's just 1. The period is 2 pi divided by 2 pi. So it's 1. So when I draw it out, I go up to 1 and down to a -1. And I just want to complete one full period by the time I get to 1. Okay, so we're starting out with cosine, so we start at the top. And we hit each of those marks. It has to start again once we get to 1. Makes sense, because now when I start it again, I guess I did say include 2 full periods. So where should it end? It should end at 2. Now you could do the period in the other direction too, like you could go this way. That would be fine. You would just have to end at -1. Does that make sense? Okay. All right, I think you guys can definitely do 3 sine of x. 3 sine of x looks just like sine, except it goes up to 3 and down to -3. So it's going to go up, down, down, up, like that. All right, and the very last thing, it talks about phase shift of sine and cosine. So it says the phase shift is the amount of horizontal displacement or change from its original position. So it's not how much you're moving right or left. So it ends up being C over B. So it says find the amplitude, period, and phase shift. So let me do one of these for you guys. So for this one, this is where you have to pull out the 6. So what would I have instead of pi? I would write what? Pi over 6, exactly. So when I multiply it back in, that's how I get pi. So this is moving to the left pi over 6. Oops, left pi over 6. We have a horizontal compression by 6, or 1/6, I guess I should say. And then amplitude of 3. Okay. So these get a little bit tricky once they shift, because we're so used to doing the 2 pi pi thing. So just kind of go over a little bit by pi over 6 for each one, and then go from there. So basically, we're going to have amplitude of 3 and horizontal compression. Oh, I guess I forgot about the horizontal compression, didn't I? So maybe we should figure out what the period is first. So what's the period then? Yeah, it ends up being pi over 3. So it means you want to complete one full cycle by the time you get to pi over 3. But you really want to start at pi over 6. So pi over 6 plus pi over 3. That's 2 pi over 6. So 3 pi over 6 is pi over 2. That's going to be your ending point. So it's going to start. It goes up, down, and then back to that starting position. Does that make sense? It's kind of weird. So you got to play around with your fractions on those ones for sure. All right, so let me pass out your homework due dates.